Good morning, students. I am Vikram Singh Rathod, Assistant Professor at Center for E-Governance. Today I am representing Python Pandas basic functionality. In this e-lecture, we are defining the Pandas library's basic functions. Those are used in various type of codes that is used in Python as using the Pandas library. So first of all, we learn about the three Pandas data structure. In our previous lecture, I am defining the Pandas library as structures as a data frame using list structure, tuple structures, and series structures, dictionary structures, and how to create them. We will majority focus on the data frame object because of its importance in the real-time data processing, and also discuss a few other data structures. Those are belongs to Python libraries, Python Pandas libraries. So I'm giving here a basic functionality of the Pandas libraries. So I'm giving a table here, a serial number or a attribute or method and description. The attributes, those are used in our programming codes such as access, data type, empty, endim, size, values, head or tail. Those are the attributes. Basically today I am describing in our programming code of Python. Basically access return the list of the row access label, and data type return the data type of the object, and the empty return the true if series is empty, and the number of dimensional return the number of dimension of the underlying data that is used in the code by definition 1, and size return the number of contents in the underlying data structure, that is a dictionary data type or a list data type, that's anything you can use, and the value return the series as a ND array type data structure, and the head option is return the first n number of rows in a data frame or the data structure, those you define in your code, and the tail option return the last number of rows that is defined in the data structure in your code. So that's why I am defining one by one example given in our today's e-lecture. So first of all, I am creating a series and see all the above tabulate attributes operations. So first of all, the main libraries, those are used in our code. I am import pandas as a PD and import numpy library as a NP. Pandas for the basically the operations on a data frame, and the numpy is used to the operations using the numbers, those are used in our programming code. So first of all, I am giving a message tag has, it's defined create a series with 100 random numbers. So I am create a s variable, s is equal to pd.series np.random.rand and put 4, and then after print s, our output is giving you in the slides. You can notice that here are the numbers randomly choose by the random options of the NP library of NumPy library, those are defined here, and also data type is float 64, and the first option of our data type or the elements those are used in pandas is access. It's written the list of the labels of the series, I am giving a example. First we import the libraries, then after create a series of with 100 random numbers, and then create a s variable is equal to pd dot series method is called, and put the bracket and call the alias name of numpy as a np dot, and then call the random method, and then call the rand function, and then put the values as a 4, and I am defining a print code as a label using as the output the accessor, and then print s dot access, and after executing the output is given in the slides. You can notice that the access are the range index start from 0, stop at 0, and step by 1. It is basically defined in the loop structure of 4 loop data structure in Python, and the above result is the compact format of a list of values from 0 to 5. That's why 0, 1, 2, 3, 4. And the second option is empty. It returns the boolean value saying whether the object is empty or not. So your answer is as a boolean type true and false. So true indicate the object is empty, and false indicate the object present in the data structure that is defined in your code. So first import the both libraries. Then the series option of the pandas library is defined as a s is equal to pd dot series np dot random dot rand n, and put as an argument 4, and print option is the object empty, and then print s and put the argument empty, and after execution the output is defined as a false because you put the argument in the s variable. So your answer is false. Then defining the endim. Basically endim is defining the dimension that is used in the data or objects you use in the code. By definition a series of 1D data structure, so it's written dimension. First of all you import the both of libraries, and then defining a comment, create a series with 4 random numbers, and defining the code pd series np random dot rand n, and put the argument as a 4, and then print s, and then I am defining the label the dimension of the objects, and then print s dot endim method is called, and after execution you saw the output. The one row is defining the index number, and the another row is defining the random number of defining as per endim, and its data type is float 64, and the dimension is 1. You can notice that the 2 column is defining here and the dimension is 1. That's why the 0, 1, 2 and 3 is a by default created a index number that's not count in the dimension. So the structure of the one number of series is, so that's why it's called a one dimension object. Then after I am defining the size, it returns the size or length of the series. It means the number of contents those are present in the series, number of occurrence of the content in a series is counted by the size option. So first import both libraries, then put the argument and create a variable s is equal to pd.series and np.random rand n and put two argument as an argument and then print s, then defining the label at the size of the object and then print dot s dot size. After execution, you notice that the two elements of the series is printed and also data type defining here the size of the object is 2 and the numbers are defining in the after execution the object size is 2. For your convention, I am defining the code screenshot to write the above code and run the Anaconda environment. You can easily run it and execute it. Then after I am defining the values, actually it will return the data in the series as an array. So I am create s variable and is equal to pd.series np.random and put 4 as per the previous code. I am defining here the actual data series as a labeled and write single code as a print s dot values. After execution, the output is giving you 0 1 2 3 is the index number and it's defining the another number of series as the values and the actual data series is defining in a list type data structure. You can notice it, the numbers those are created is defined in a list type structure. And then after head and tail, to view a small sample of a series or the data frame object, use the head and the tail method. The head return the first n number of rows. Observe the index values. The default number of elements to display the is 5, but you may pass a custom numbers using the code defining. So I am giving an example. First of all, import both libraries, then create a series of 4 random numbers such as s is equal to pd.series np.random.randn and then put the argument value 4 and the print option the original series is and then print s, it print the series as a s and then after I am defining a labeled using the print option the first 2 row of the data series and then define the head using with print option s dot head and then put the 2 number. It's after executing it's define the first 2 row of the data structure that is used in our code and after executing it return the output. You notice that the first print s return the total number of 4 values and the second print dot head execute it's return the only first 2 of values of our data that is defined in our np.random.rand series. Then I am defining the tail method. It return the last number of rows. By default the number of elements to display is 5, but you may pass a custom numbers as per defining as a head. You can defining in the code as the tail using the code. First of all, you import the libraries, then create the series using a variable s, and then print the original series. It print the total number of elements, and then print a labeled the last two row of the data series, and then write the main code of tell method using the print option s.tell and put two arguments. It's return the last two values of your data structure. So after execution of the code, the original series is generated by the as the output you can see in the slide 0 1 2 3 4 and related number. And after executing the tail option using the number of two rows, defining the last values of the series 0.969457 and 0.146748 is your last two numbers. Those belongs to your data series is your answer after executing the tail method. For your convenience, I am defining the code in Anaconda environment using spider tool. You can easily see the code and execute it on your computer, on your laptop. Then after I am describing the another concept of data frame, basically functionality of data frame. Let us understand what is data frame. Basic functionality is the following table list down the important attributes or methods that help in data frame basic functionality. Let us know to create a data frame and see all how the below mentioned attributes operated. Because I am defining the data frame in our previous lecture, so I am use some descriptions of the data frame. So first of all, you import the both library and create a dictionary type data structure. I am create a variable d as a dictionary data type data structure and define it's in the curly brackets, and defining the key object as a name, age and rating of the key values of the dictionary. And then after I am called the pd as a alias name of pandas, and then after creating a series values, I am putting the some string variables in the name value space or name value key values are such as Rakesh, Sunil, Rishi, Vinit, Sumit, Shyam, Ram, and age option pd.series. I am defining the age of the above names such as 20, 22, 24, 26, 28, 30 and 32. And then after the rating option, I am print the rating in the float number. You can notice that defining here as a rating pd.series and then create a data frame. So I am defining a df as a variable for data frame and is equal to pd.data frame, and then put the dictionary in the data frame and then print a labeled option, print our data series. And then after I am printing the data frame, I am defining the print and put the data frame into it as an argument, and after execute it creates the series. You can notice that as per the key values of the dictionary, name, age and rating, you can notice that it execute a tabular form as an output. Then after I am use a transpose option of the data frame. Basically it transpose the data frame, the row and column will interchanges. Transform option is used for convert the row into column and column into the row. So first of all I am importing both libraries and create the dictionary as per the previous example, name, age and rating, and then create data frame as a df is equal to pd dot data frame, and put the dictionary as an argument, and then print the message as a the transpose of the data series is print df dot t. And after execution you can notice that it converts our data that is run in our previous slide in the columns. You can notice that the column is converted into the rows. First row is name, second row is age, and third row is rating. You can notice the code and execute the code in given slide. And then after I am defining the save option of the data frame, it returns the tuple representing the dimensionality of a data frame, tuple a comma b, where a represents the number of row and b represents the number of column. So first of all you import the both libraries, then create the dictionary as per the previous example. The dictionary is created as a d and define using the key variable name, age and rating and corresponding values using the pd.series. And after that I am create a data frame as a df is equal to pd.data frame and put the dictionary as a d, and then defining the label our output as a print option, and then print the data frame and put the df data frame as the print option. And then after I am defining the label method after executing the save of the object as a print option, and then the last code that is define its data frame shape. I am writing here print.df.shape. It return the size of the number of rows and columns as a output. You can see in the slide the name, age and rating, and the index number is also defining here 0 to 6, and the name option is corresponding names are also defined, and age related option defining age and rating option defining the rating numbers, and the shape of the object is returned as a output the 7 row and 3 columns, as the shape is your dictionary type data structure that is defining in your code. And then after I am defining the size, it return the size of the data frame. So basically I am defining the both of the libraries and create a dictionary as per the previous example, d dictionary, and create a data frame df is equal to pd.data frame and put the value as a d, and print option our object is, and print the data frame into print option, and then print a labeled message the total number of elements in our object, and then the main option using the print df dot size, it return the total number of elements in our object. After executing it given the total number of the objects that is used in our dictionary. So you can notice that the objects 0 to 6 name, 6 name and 6 age and 6 rating, the total number of elements in our object is 21, and the index is also counted here. For your convenience, I am defining the Anaconda environment code. To use the programming code, you can easily write the code using Spider or Jupyter or R Visual Studio Code or any type of environment provided by the Anaconda. I am defining the code in Spider You can easily see the code and write as per your convenience. You can write the code and execute the code. Thanks students. Our official channel CEG's APR is providing number of subjects e-lecture on the electrical, automobile, computer science, chemistry, etc. Number of lectures are provided on our official channel CEG's APR. You can learn and understood the concept behind it. Thanks.